Hello everyone, greetings from IBAT Robotics Club. IBAT Robotics Club, that is IRC, is going to start its second workshop on line follower robot. We are looking for new members who are really active and self-motivated. So, who want to join with us? Start your preparation and get ready for new challenge. Because of an because of a technology related club, IBT Robotics Club needs active members. So club committee decided to find out active members among our students. We will upload some tutorials on our basic components, basic studies. So who you are interested in robotics, you have to follow the direction and study in your home, and after that you will participate in a exam for enrollment. Interested person who will pass the exam, they will get the chance to join our workshop. So this is our uh, first tutorial for our examination. So please take patience and stay with us. Today we will talk about very basic parts that will work with every day when we work with robots. So start from very beginning. We are going to start from very basic. So first one is what is current and what is voltage. So current is the flow of electron. Very if I say simply, that is flow of electron, and voltage is the uh, pressure of electrons, which pressure the electron are flowing. So if we imagine there is a water tank uh, behind this tap, then the waters are the electrons, and water flowing through this tap, their current, and the pressure in which the water is coming out, that is our voltage. So if the pressure of this tap is high, then the flow of water will be high. If the pressure of the water is low, then the flow of water will be very low. Like this one is the battery. The battery has so many electrons and holes. Electrons are negative and holes are positive. When they are connected to a load, the electron will flow from negative portion to positive portion, and uh, the rate of flow of electrons will depend on the pressure across this two terminal. So we get two terms, that is current and voltage. So if we want to measure these, what we will use? An multimeter that has several option that it can measure. Here is a figure of an multimeter and a circuit. uh, Now an we have a measuring equipment, that is multimeter is a multifunction meter. That means it can measure several kind of quantity, like current, voltage, frequency. Diode can conduct some test, like diode test, frequency measurement. So we can use this meter in various ways. So if we want to measure our current, we have to connect this meter in series to that circuit in which we want to measure the current. And if we want to measure the voltage across any circuit, then we have to connect this the voltmeter, that is in multimeter. This pointer will be here, so it will be used as voltmeter. So and across the connect across the load or measured device, measured device which one we want to measure, across that load. If we connect through like this, then we will find out the voltage. Here you can see that DCV, that means DC voltage is measuring here. So our previous one was the series circuit, this one is ammeter, so this one is series circuit. Current will go through this meter and out from this meter and go to the load and come come back to the power source or battery. If the meter is broken or disconnected inside it, then the load will not work, so that is series circuit. And if we think about this, the positive terminal of battery connected with the load and negative terminal also connected with the load, and across that load we have used this meter. If the meter is broken or disconnected inside it, then the load will work its own way. That means the effect of load will not affected by this meter. So this one is parallel connection. So how the measurement is happened, I think it is clear to you. Now we are going to talk about some basic components. First one, the transformer. Transformer is a device that convert or that will not convert, that is transfer the electric power from one place to another place without direct electric connection. It is very basic definition. So if we see that here two coils in a transformer, and there will be no electric connection, that there will be a magnetic path between these two coils. If we connect AC 220 voltage, that is our main supply voltage in our home or outside, then it will a step down or a step up in secondary section. Usually we will use this type transformer, and we will connect AC 220 voltage and we will get AC 12 volt. Now here is another basic device, that is diode. Diode is a device that allows to pass electricity in one way and deny from another way. So the physical device is like this, and the symbol is like this, and the terminal name is anode, cathode. Anode, cathode, and why we will use in practical device, that is our practical device. And if we observe it, then we will see a silver bar or silver line in the body of the diode. So this bar as the symbol, the bar of the symbol. So the bar side is cathode, and the opposite side is anode. So this way we will remember the terminal of this device. We will use this device to convert AC to DC, alternating current to direct current. We will talk about it later. Now another basic device, that is capacitor. Capacitor is a device that stores charge for a very short time. We will use this device for filtering, and how it filter we will talk about it later. And the pin is in case of electrolytic capacitor, you have to remember about pin configuration, that is one terminal is positive and another terminal is negative. So how we will find it? The if we observe on the body of this capacitor, here is the negative marking here. So uh, the closer terminal is the negative terminal and the opposite terminal is positive terminal. Another way you can understand or find out the pin of capacitor: the big one is positive and the short one is negative. There are several kinds of capacitor we will use. Here you can see electrolytic capacitor and ceramic capacitor. Sometimes we will use paper capacitor. Several type of capacitor we can use in our circuit. In case of ceramic capacitor, there will be no polarity, or you don't think about any positive or negative terminal. Only in polarized capacitor or electrolytic capacitor you have to remember the polarity or find out that polarity. Sometimes ago we have talked about the diode. So several diode we can use for several purpose. Here is a type of diode, that is light emitting diode. That means it's also allow the current in only one direction, but the specialty is when it is forward biased and the current will flow through this device, then some lights will emit from this device, so we can get some lights. So here are several types of LED here. The basically we will use this device to indicate something, something like it will show the state of the terminal of circuit, that is high or low, or it's on or off. It will show the state of the terminal. So we will use this device to indicate something, indicate any point, how it is working. We can see, we can find out through this device. And the symbol is as like as the diode, only the arrow sign is added to here, but the symbol is as like as our diode. Now another device is resistor. Here are some carbon resistor. Maybe it is quarter watt, very small resistor. In figure it could be it seems like very big, but it is very small sized resistor. And resistor is a device that deny the flow of electricity, or it opposes the flow of electricity. When electricity passes through this device, it it resists the flow of electricity. So we will use this device to voltage divider circuit or various circuits to voltage up or down, or when we need appropriate voltage to any point, we have to calculate the values and connect this device to that circuit. And another interesting thing is the color code of that device. We don't need to use the ohm meter to or measure the resistance of the device. If we know the color code, easily we can find out the value of that resistor. Just observe the color and find out the value of that color from the table and calculate the value from a very simple law. We are not talking about the color code. If you want to be expert on electronics, you can memorize it. Several resistors in several resistors are available in market. Here are some resistors you can see here. These are resistors. Okay. Maybe this one is quarter watt resistor. These are 1 or 2 watt resistor maybe. And here if you see here, that is high watt high wattage resistors here. If you see, this one is 4 watt resistor. So here several resistors we will use for our work. And now there is another resistor, that is variable resistor. It's like the volume of our amplifier. If you use amplifier to listen song, you can turn this device from left to right to increase volume. So this that one and this one is the same device, that is variable resistor or pot. And the function of the resistor is, previous resistors, these are the fixed resistor. If this one is 1 kilo ohm resistor, it will always 1 kilo ohms it will be always 1 kilo ohms resistors. If we increase the current or voltage, it will tolerate maximum 5%, but the value will be about 1 kilo ohms. But in case of variable resistors, it will vary the voltage from 0 to its maximum value. If we consider this one is 1 kilo ohm variable resistor, then these three terminals will represent the value, or this 3 point will be connected to our circuit to use the variable resistors. And if we use this n terminals, we already considered this one is 1 kilo ohm variable resistor. If we connect this n terminal to circuit, then it will show that it is 1 kilo ohm fixed resistor across this two n terminal. If we use this two terminal and middle one, then middle one is variable terminal. That means reference from this point to this middle point, the resistance will be low to high or high to low, or reference from this terminal to this terminal, the resistance will be high to low or low to high. That means when we use this middle terminal, the resistivity of this device will be changed through this knob. If it is turned left to right, the resistance will be high, taking high value or low value. If it is turned right to left, then the value will be low or high. Now here is another device, that is our transistor. Transistor is like three terminal device. The terminal name is base, emitter and collector, and the type of the transistor is NPN and PNP. So what is the function of the transistor has so many uses, like it can switch, it can use as a electronic switch, it can use as a amplifier device, it can use as inverters. It has so many uses. So in case of our work, we will use this device as a switching device. So here is the two symbol of the devices, or it could be similar, that means BC548 or and C18C, these are as like a same device. If we follow the physical size or physical view of these two devices, they are same, but it could be possible that this one is NPN and this one is PNP, but the symbol is different. That this one is NPN transistor and this one is PNP transistor. And if we follow that, if we observe that this two type transistor have same three terminals, that those are base, collectors and emitters. Collector, emitter, base, they are using to switch any circuit electronically. When you use transistor as a switching device, if our trigger voltage is positive, we will use NPN transistor, and if our trigger voltage is negative, we will use PNP transistor. Before explaining this, I am going to talk about how transistor works. If we think about this symbol, the collector to emitter, the resistance will be very high without the base supply. So when the absence of base trigger, that means base is opened or base is not triggered, then the collector and emitter resistance will be very high, so current will not pass through this line, collector to emitter. It will it cannot pass from collector to emitter. If the base is triggered, then that means if NPN transistor, the positive power supply is connected to base, or in case of PNP transistor, negative terminal of power supply connected here, then collector to emitter resistance will be decreased. So current will flow through this path very easily. So collector to emitter will be as like as a conductor. So when we trigger the base, the respected circuit that is connected with collector and emitter, it will turn on. Here is a example. Here NPN transistor, that is 2N3904, that is an that is a NPN transistor. Here when this is open, the base supply is open, then LED is off. When it is connected to the power supply, then the LED that is connected to the collector and emitter connected with ground, then positive supply connected with resistor, and after that the LED, and collector to emitter, it will go to ground. So the circuit is completed. When it is turned on, the LED is turned on. When it is turned off, LED is turned on, because when it is turned off, the resistance of the collector to emitter will be very high, so no current will flow through this VCC to ground, so LED will be turned off. Again, this one is about NPN transistor. Now PNP transistor, if we think about it, here collector is connected with VCC and a load that is R11, that is 1K. A load is connected to ground to emitter, and the output terminal connected from emitter to any outside connection. If when it is connected to ground, it is VCC, that means this VCC comes here. If there is open, it is 0 volt, that means it is disconnected from this VCC. So when it comes when it connected with ground, the base when connected it with ground, we will get the VCC or collector voltage to this point. When it is connected disconnected from this, it will be 0 volt. The emitter voltage is 0 volt, emitter to ground voltage. So that's all for today. We'll post our second tutorial very soon. Just stay with us and tuned our website, that means our Facebook web page. You will get the update news from there. That's all. Thank you.